Hey there, this is part 2 of our section 9.1 notes where we're discussing hypothesis testing with two proportions. So we're going to do the confidence interval method. So we already did the p-value. There's also the critical region method. So let me talk about that for a little bit before we do the confidence interval estimate for p1 minus p2. So when we found our test statistic, we found our standardized statistic that it was 9.29, and so I graphed it here, though this is not necessarily to scale. So it says find the corresponding p-value or find the critical region. So how do you find the critical region? So let me redraw our bell curve. Now we were given that our alpha was 0.05. This is the level of significance. So and this was a right-tailed test. How do we know that? It came from the alternative hypotheses. So look at the sign of your alternative hypothesis. If it's greater than, you have a right-tailed test. If it's less than, you have a left-tailed test. If you have not equals, then you have a two-tailed test. So because this is a right-tailed test, that means that we want the area over here to be 0.05. So the critical region is oftentimes defined by an upper limit and a lower limit. So this will be our critical value for the upper limit, but then we need a lower limit. And because of symmetry, we can say then that this is going to be also 0.05, right? So then that means we're going to be looking at the area to be 0.05. So when you look at our z-scores, because our table gives us the area to the left, that's where we want to look at for the area to be 0.05. And so 0.05 is right in between these two. So it's 1.645 is our z-score. And you can see here at the bottom 0.05, the z-score is negative 1.645. So that means that this is negative 1.645, and then by symmetry this is 1.645. Remember, we're assuming the normal curve, so we're assuming that the middle is 0. So when we standardize our statistic and we get this is now taking our proportion, which is, what was it, the 0.131, and is putting it, trying to normalize to put it in the where the mean is 0, and we get that our z is 9.29. So this is our standardized test statistic. So where is it? Does it fall in the critical region? Yes, 9.29 is going to be way over here, right? 9.29. So that will be in the critical region. So this here is the critical region. So because our standardized statistic falls in the critical region, so meaning our 9.29 z-score is greater than the 1.645 z-score, then we reject the null. So you reject the null hypothesis when your standard statistic falls in the critical region. So that's these two are equivalent because we are using essentially the p-value method. Now for the confidence interval method, we are using, notice that here our standard error is strictly data from the sample. So this one, the confidence interval estimate, is not as strong as the p-value or the critical region estimate. So, but oftentimes there may be reasons why we might want to do the confidence interval to decide whether to reject or not to reject the null. But usually the universal method is the p-value method or the critical region method, those are equivalent. So we're going to go to StatCrunch and follow the instructions on StatCrunch to find our confidence interval for the difference in the proportions. So we're going to go to StatCrunch, click on Stat, and then select Proportion Stats from the drop-down menu. And then we're going to select the to sample with summary because we have all of this data, right? We have our P1 hat, we have our Q1 hat, and we have our level of significance. So let's go to StatCrunch. Alright, so once you're logged on and you're in StatCrunch, you don't need to select any specific data. You don't need to have any data in here because we're going to use the summary. So we're going to go to Stat and then select Proportion Stats. And then we have two samples. And then notice that here it says with data or with summary. We're going to do with summary. In the homework, sometimes you may have some data in here, and then in that case, you're going to go with data. But here, just with summary. And then it asks you, what is the number of successes? So we had for sample 1. So we have 40 successes. This is the number of deaths that occurred while Gilbert was working. And then number of observations, how many shifts did she work? That was 257. Sample 2, what is the number of deaths that occurred while she was not working? That was 37. And how many shifts did she not work? And this one, what was this one? 1384, if I remember correctly. We can quickly go back and look. Our table, yeah, 1384. And so back to StatCrunch, and let's see, hypothesis test for P1 minus P2, so equals 0. That's correct, but here our alternative is that we think is greater. We have a right tail test, and our level of significance is 0.05. If I wanted to do, like say 0.01 or something different, I'll click on show critical value, and now you can change it to whatever the alpha is given. And from here we can click on compute. So let's click compute, and here's our result. So notice that it gives us the null and the alternative, and it gives us our sample difference, which notice is 0.1289. We had gotten 0.123, so it's really close. Notice that our Z statistic or Z score is 8.97. Something is off. Did I input something wrong? Let's go to edit and see. It was 34. Should be 34. Not sure why I put 37 there. Now let's hit compute and see. So this is why it's helpful to also do it by hand, because then we can see. Sample difference, there it is. Okay, 0.131, so that's what we had gotten. And then our Z stat is 9.29, so that's what I was looking for. I'm like, wait a minute, we shouldn't be that different. Notice that our critical value is 1.64. So going back to our written notes, notice 1.645 is what we got from the table, and our test statistic, or standardized statistic, or Z-score, 9.29. So that matches our StatCrunch details. So for the confidence interval, then we're looking, so this is the hypothesis testing. So if we go to, let's go to edit, and we want the confidence interval for P1 minus P2. Now the confidence here is not going to be 95, is 90. And why is that? The reason that we're doing a 90% confidence interval is because since this is a right tail test, right, our critical region here is 0.05. This has to stay 0.05. So when I do symmetry, this is also 0.05. So 0.05 and 0.05 on the two tails gives me 10% of the data. So that means that in the middle here, we have how much? We have 90% of the data. So when I have a right tail test with a level of 0.05, this means I have a 90% confidence interval. So going back to my StatCrunch, here I would, since I'm no longer doing a hypothesis test, here I was just doing that to check our work. And then here, confidence interval, 90%, compute, and it gives us our confidence interval, lower limit and the upper limit. So we can copy just these two into our notes. Oh, it's not gonna let me just copy them. So lower limit is 0.093 and upper limit is 0.168. So I just copied the whole thing to our notes. So here, that means that our lower limit for the confidence interval is the 0.6 0.093, so let's just round to 3 decimal places. So that is our lower limit for the 90% confidence interval is going to be less than P1 minus P2, and then the upper limit is here, the U limit, and rounding to 3 decimal places, that will be 0.169. And so this will be our 90% confidence interval. And so what can we say? How does this give us any reason to reject or fail to reject the null, any significance? Well, what was our null hypothesis? Where did we write it? The null hypothesis was that P1 minus P2 is 0, right? So is 0 contained in this interval? No. Notice that 0 is not contained in here. So because 0 is not contained in the interval, we can then we reject the null. So we can say we reject the null hypothesis. And notice also that the interval is positive value, so that means that for P1 minus P2, this confidence interval says it's always positive, so that means that P1 has to be larger than P2, which is saying that the claim that Gilbert's death rates are higher is plausible. So that's how you use a confidence interval to make a decision about whether you reject or fail to reject the null. So keep in mind what the null is. The null says P1 minus P2 is 0, but then our confidence interval here does not contain 0, so that means we reject the null. If it did contain 0, that would mean that one side will be negative, perhaps like negative 0.093 and then positive something, right? To go from negative to positive, you have to go through 0. So in that case, if our null hypothesis was included in the value, right? The value of 0 was included in our interval, then we say, oh, then it's possible, so then we fail to reject the null. All right, let's go try an example from your textbook, from your homework. All right, so this is an example that might be similar to the ones that you get in the homework. So everything is a word problem in statistics, right? Well, mostly everything. So let's read the problem. So it says, in a study of treatments for very painful cluster headaches, 156 patients were treated with oxygen and 151 other patients were given a placebo consisting of ordinary air. So there's other stuff going on. So just in reading that, what would you say this is? Observational study or experiment? Okay, you have a placebo and you have patients that were treated, so this will be an experiment. Okay, let's continue. Among the 156 patients in the oxygen treatment group, 107 were free from headaches 15 minutes after treatment. Among the 151 patients given the placebo, 36 were free from headaches 15 minutes after treatment. Using a 0.01 significance level to test the claim that the oxygen treatment is effective. So complete parts A through C below. So test a claim using a hypothesis test. Okay, so we want to know then which hypothesis is it? What's the null and what's the alternative? So if we want to test the claim that the oxygen treatment is effective, so that means either the proportion of patients with the placebo and with the treatment is the same or it's not. Right, so then the difference, oh, this one doesn't do the difference. So then this one we will do, now remember the null hypothesis has to have an equality. So we can get rid of B and, well, that one is the only one we can get rid of. So, but it has to be, so it's probably this one, has to have an equals, C or F. So, because either they're the same or they're not. And if the treatment is effective, which one will be higher? If the treatment is effective, then P1, the proportion of people in the treatment group, will be higher, right? So then that means you want P1 to be greater than P2 if the treatment is effective. So you have, so it will be F. Oops. So in case that was a little bit jumbled up as I was trying to explain it. So when you're trying to identify your null and alternative hypotheses, you're trying to see your null hypothesis is going to be that P1 minus P2 is equal to 0 or P1 equals P2, right? The proportions are the same. So then when I look at my options, well, it's going to be either C or E, because my null is either that they are the same. And then looking at for the alternative, then I look at my claim. The claim is that the oxygen treatment is effective. So if the oxygen treatment is effective, that means that the proportion of people getting the oxygen treatment should be higher, right? Should be with the treatment should be getting better. So P1 is greater than P2. So we can try that, and then let's check our answer. So check your answer. Okay, so we got that one right. Now identify the Z statistic. And so here is where then you would go, and we can do it by hand or we can use StatCrunch. So if we use StatCrunch, we will do it with summary because we don't have the data. This one doesn't give us a link to have the data, but it will be a good idea to write this in a 2x2 table and organize your numbers so that you can get your proportions. So as you work these problems, try to create your 2x2 table. So let's put in our data here. So let's see, we have 156 patients were treated with oxygen. So that's the treatment. So there was a total of 156 patients, and then 151 other patients were given the placebo. So total for the placebo will be 151. When you add those up, the total is 307. Now the next piece of information tells us that among the 156 patients in the treatment group, so of this 156, 107 were free from headaches 15 minutes after treatment. So 107 were free of headaches. So how many still had a headache after the treatment? So do 156 minus 107 to get that number. Now of the 151 patients that had the placebo, 36 were free of headaches 15 minutes after the treatment. So let's put 36 here, and same thing, to find this number, do 151 minus 36. So the top one should be 49 for the treatment, and then the other one will be 115. Now the totals here, 107 plus 36 gives me 143, and 115 plus 49 is 164. Now these 143 plus 164 should still add up to 307, which it does, so everything so far is matching up. So to find our proportions, our p hat, I'm just going to call it p hat treatment, will be then 107 free of headaches out of the total treatment, which is out of 156. So I set up my table a little different than the other one, and then with the one with the nurse. So p hat here for placebo, I'm just going to call it placebo instead of P1 and P2, equals then 36 were free of headaches out of 151 total in the placebo group. So those are our proportions. So 107 out of 156, 36 out of 151. So now let's go to StatCrunch. And so once you're here in StatCrunch, it will be nice to have the instructions handy. So from the notes that I gave you. So we go to Stat, and we're going to go to Proportion Stats, and we're doing 2 sample with summary, right? We don't have the data populated here, so we're going to go with summary. And so number of successes in the first sample, so that's what we just found. So it was 107 out of 156. So that's why we found our two-way table. So 107 out of 156, and then the next one for the next group, the placebo, is 36 out of 151. So put in your 36 out of 151, and we're doing a hypothesis test. What was our level of significance for this problem? So looking back at the problem, we were told to use a 0.01 level of significance. So we're going to do 0.01, going back to my StatCrunch. So we're going to show critical value and change that to 0.01 and then compute. And so it gives us here our null hypothesis. Oh, we didn't change it, right? I should have changed it to greater than. So edit and make sure that this matches our alternative. So greater than. And now let's hit compute. So always make sure that you check that what you're inputting matches your written null and alternative hypotheses. So now I do have the greater than there, so that means we're good. So here's our standard error. Here's our z statistic. So if I want to do it by critical region, I can say 7.85, and here's our critical z value, 2.32. Here's our p-value, 0.0001. So based on this, what can you say? But let's go back to the homework and see how do we put in all this data that StatCrunch gives us into the different parts of the homework. So here it asks me to identify the test statistic. So we're gonna put that in here based on StatCrunch. So what did we have? The test statistic is our z-stat, so 7.8579. So, and we want to round to how many decimal places? Always pay attention to what the homework is asking you to do. So we want to round to 2 decimal places. So we're going to say then that our z-statistic is 8579, so we're going to say 86 because it asks us to round to 2 decimal places. Check the answer and we got it right. We can go on. The p-value. So what is our p-value? So going back to StatCrunch and look at the data, the p-value is 0.0001. So we can use that on our homework. So 0.0001, and then check answer. Oh, what happened here? The p-value is the probability. Okay, let's see. Did I not place it to? It says round to 3 decimal places. So I just put 0.000 and then now it accepts it. So so back to, I don't normally do my MyLab homework, but pay attention. It's really important to pay attention to how many places they want you to round. So round to 3 decimal places. What is the conclusion based on the hypothesis test? Our p-value is less than, right? 0.00 is less than 0.01. So our p-value is less than the significant level of 0.01. So what do? Do we reject or fail to reject? We reject the null hypothesis. So there is sufficient evidence to support the claim that the cure rate with oxygen treatment is higher than the cure rate for those given a placebo. And then check your answer, and that should be good. And then we move on to test the claim by constructing an appropriate confidence interval. So here it tells you already the 98% confidence interval is. And why is it 98? Again, that's because this is a right tail test. Going back to our alternate hypothesis, right? It's right tail. So that means that, let me go back to the picture that I had before, right? So here you would want then 0.01 here and 0.01 on the other side. So that gives you 2%. So that means the middle will be 98. So that's where you're getting the 98%. And so we would put in the 98. So going back to StatCrunch, because you can still do this with StatCrunch, we will just go to options here and edit. And instead of hypotheses, you will go to confidence interval, and the level of confidence is 98%. And you will do compute. and now you have here your lower limit and your upper limit. So 0.329, and again, let's pay attention to how many decimal places we want to round to. Now notice it tells us to round to 3 decimal places as needed. So let's make sure that we don't make the mistake of rounding to the wrong place. So this will be 0.329 for the lower limit because it's to 3 decimal places, and then the upper limit will be 0.5657, but because we want to round to 3 decimal places, it will be 0.566. And then check your answer, and we rounded okay. So what is the conclusion? So notice that our null hypothesis was that P1 equals P2, so that means P1 minus P2 equals 0. So 0 is not in this interval. So we will say because the confidence interval limits do not include 0, it appears that the Q rates are not equal because the confidence interval limits include only positive values. Right, notice the confidence interval is all positive values, which will mean that P1 is greater. So it appears that the cure rate is higher for the oxygen treatment than for the placebo. Because it's positive, P1 is higher. If both of these were negative, then P2 will be higher, right? Because if you're doing P1 minus P2, in order to get negative numbers, that means that the one you're subtracting is larger. In this case, you're subtracting 2 quantities and you get positive. That means that the first quantity is larger. Check answer. It's so positive. It tells you good things when you get it right. Based on the results, is the oxygen treatment effective? So what would you do? So pick one of these from here, right? This is essentially the on a quiz or a test, and when I ask you to show your work, this will be essentially the ones that say write your conclusion in the context of the problem. So from here, you will pick one of those. So which one should we pick? We should pick the one that says that the oxygen treatment is effective. So it will be B. And that's it. And so then we will be done with the question. So I just wanted to do something that is from MyLab, because I know that when I do the examples in the video, sometimes and then you go to the homework, it's different because it's just presented different. So hopefully this gives you an idea and helps you do your homework. And also I wanted to show how to use StatCrunch with your homework. So email me if you have any questions.